Okay, this is Honors Pre-Calculus, section 10.3, ellipses. An ellipse is the set of points in a plane such that the sum of the distances from two fixed points is a constant. The set of points in a plane, so flat surface, such that the sum of the distances from two fixed points is constant. Those fixed points are called foci. Focus is singular, foci is plural. And if we look at our picture of an ellipse, we have the two foci here, any arbitrary point on this ellipse, and if you were to measure the distance from P to one focus, and then the distance from that point P to the other focus, that distance, the sum of those distances, is constant for this ellipse. There is some important vocabulary and information about ellipses. For an ellipse, there's a line of symmetry right here, a longer line of symmetry called the major axis. A minor axis is another line of symmetry, and it's the shorter one. This point right where the major axis and the minor axis intersect is the center. These points here where the ellipse intersects the major axis, that's a vertex. So let's put this over here. Vertices occur where the ellipse intersects the major axis. The foci are always on the major axis. There's one focus. Here's another focus. These are always on the major axis. Very often with ellipses, we talk about the length of the major axis, and the length of the major axis is the distance between the two vertices. The length of the major axis is the distance between the two vertices. Okay, now there is a general equation for an ellipse centered at HK. Again, slightly different than the text, but that's okay. We can work with this. The general form for an ellipse centered at HK looks like this. X minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. And additionally from here, c squared is the absolute value of a squared minus b squared, where c is the distance from the center to the foci. All right, let's go ahead and take a look at an example so that you can see how all of this information plays out and how it all fits together. If we look at this ellipse right here, this first one, x minus 2 quantity squared over 4 plus y plus 3 quantity squared over 16 equals 1, we can find the center. The center is HK. So 2, negative 3. Here's the center. 2, negative 3. All right, now to graph this, what we do is we look underneath here. Underneath the x's, that's 4. The square root of 4 is 2. That means in the x direction from the center, the ellipse goes out 2 units in each direction. Look under the y's. 16, that's the b squared. The square root of the b squared is 4. That means from the center, in the y direction, we will go 4 this way and 4 this way. Once you have those 4 points, then we sketch the ellipse in. Try to make that ellipse rounded at the ends, curvy, not like a diamond, if you will, but make it curvy. There's your ellipse. Once you have that ellipse graphed, then we can find all the other important information that I alluded to up here. The vertices. Vertices are along the major axis, which is the longer axis. Longer this way, so we can just read those coordinates, 2, 1, and 2, negative 7. The major axis, that major axis is running vertically, so it's running along this line, x is equal to 2. The minor axis, running horizontally here at y equals negative 3. The length of the major axis, well, that's 4, 4, 8. And the foci. All right, now we know the foci are always along the major axis. So the foci have to be along here somewhere. We're just not really sure where they are. Let's just arbitrarily put a point up here for a focus and another one down here. Not exactly sure where, but clearly we can see that the x-coordinate for both of those is 2. So the foci, one of them is going to be at 2 comma something, and the other one's going to be 2 comma something else. And we just need to figure out what that is. So we go back to the previous page where I told you that c squared, to find the focus, c squared is absolute value of a squared minus b squared. C squared, all right, here's the a squared and the b squared. So 4 minus 16, that's negative 12, absolute value is 12. That tells us c is, c squared is 12, so c is plus or minus square root of 12 or 2 square root 3. That's the distance from the center. So from the center, we're going to go up 2 square root 3 and down 2 square root 3. So this distance right here is 2 square root 3. So the y coordinate here is negative 3 plus 2 square root 3. And the other y coordinate is negative 3 and then down 2 square root 3. Negative 3 minus 2 square root 3. And there we go. All of this is this important information. all that important information. All right, let's look at this next problem down here. 4x squared plus a 9y squared minus 24x minus 90y equals negative 225. Definitely not in that nice graphing form for an ellipse. So we are going to have to do some algebraic manipulation here. Let's start off by separating out the x's and the y's. So I'm going to put the 4x squared minus 24x, and then I'm going to group the y's, 9y squared minus a 90y, and the negative 225 on the right hand side. From the x's, let's factor out a 4. That leaves me with x squared minus a 6x. Please leave a space. From the y's, let's factor out a 9. Again, leave a space. All right, now we go through and we complete the square. For the x's, half of this 6 is 3. 3 squared is 9, so we're going to add 9. But we really added 4 times 9 to the left side, so we will have to add 36 to the right side to keep the equation balanced. Here, half of 10, 5. 5 squared, 25. So we'll have to add 9 times 25, which is 225. All right, cleaning this up a bit. Factor this x squared minus 6x plus 9 factors into x minus 3 quantity squared. The y's, y minus 5 quantity squared equals, right hand side, conveniently the negative 225 and the positive 225 cancel out, and we are left with a 36. All right, now for an ellipse, this number over here has to be a 1. So we'll have to go through and divide everything by 36, which will leave us with an x minus 3 quantity squared over 9 plus a y minus 5 quantity squared over, squared over 4 equals 1. Now we have our nice standard form for an ellipse, and we know the center is 3, 5. I get all of my graphing done first, and then I go back and find all that important information. So 3, 5. There's the center. And in the x direction, the square root of 9 is 3. So 3 to the right, 3 to the left. In the y direction, square root of 4 is 2, so up 2, down 2. And we can go ahead and sketch in this ellipse now. And there's the ellipse. Once you have that graph, then all the other information is found from the graph. The vertices along the major axis. The major axis is running right here, the longer one at y equals 5. And the vertices then, we see one at 0, 5 and also one at 6, 5. The minor axis running vertically at x equals 3. The length of the major axis is 6. And the foci. Alright, the two foci, again, somewhere on this major axis, so right here, somewhere. Alright, now this time we see that the y-coordinate is remaining constant for these two foci, and the y-coordinate is 5, so this is going to be something comma 5, and something comma 5. Running through that, c squared is the absolute value of a squared minus b squared. C squared is 9 minus 4, absolute value of that, so c squared is 5. which means c is plus or minus the square root of 5. And then, to find the coordinate of the focus, we know that the x-coordinate of the center was at 3, so we're going to have to go square root of 5 in each direction from this point. So 3 plus square root 5 and 3 minus square root 5. And there we go. Let's look at flipping things around a bit. This time, let me give you some information about an ellipse, and you come up with the equation. We are going to find the equation of ellipse with center at 3, 7, focus is 6, 7, and the vertex is 8, 7. So sketching a quick graph, doesn't have to be perfect, but reasonably close. Center is at 3, 7. Focus is at 6, 7. And vertex is at 8, 7. So we see this ellipse doing something like this. All right, when we go to set this up, x minus something squared over plus y minus something squared over equals 1. All right, what do we know? We know the center is at 3, 7. That's nice. That fills in here as 3 and a 7 there. In the x direction, from the center to the vertex, that distance was 5. That means underneath the x direction, this needs to be 5 squared, or 25. We don't, however, know how far that we've gone in the y direction. So we need to use that idea about c squared is the absolute value of a squared minus b squared. All right, well, c is the distance from the center to the focus, and we can see that that's 3. All right, now, is this 25 going to be bigger or smaller than this b squared that we're looking for over here? 25 has to be bigger because the foci are along the major axis. So I can kind of use that idea and take out these absolute value, because we know that that 25 has to be bigger. The foci are on the major axis. So 25 is greater than the b squared. And we solve this. 9 is 25 minus b squared. B squared is 16. You do not need to do the square root because you are looking for that number right up here, which is b squared. So 16 right there. There's that ellipse. Okay, there is an application for ellipses. It is called a whispering gallery. And the whole idea behind the whispering gallery is this is kind of a cross section of a room. Here's the ceiling. Here's the floor. And the walls curve down here, so you don't have a right angle at the wall to the ceiling. There's a curve here. You can kind of see it down here in this picture of this whispering gallery at Grand Central Station. And the idea behind this says that if you are standing at a focus, that all the sound waves coming out of your mouth, even if you are facing away from a person standing over here at the other focus, that sound wave will focus back right in on them. So any sound wave coming out of here will focus back to that person over here, and they will be able to hear you clearly. Oh. Okay, sorry, my computer shut off. Hopefully you heard that. If you get a chance, go search out on YouTube Grand Central Station Whispering Gallery. There's a couple of really neat YouTube videos up there that you could go and watch and see how a whispering gallery works. It's kind of cool to watch it. One guy ends up proposing to his girlfriend in the whispering gallery, and it's kind of fun to watch. So if you get a chance, go search that out. But let's take a look at this example that says we have a young man, Nick, who is standing at one focus of a whispering gallery, and he is 6 feet from the nearest wall. His friend Kaylee standing at the other focus 100 feet away. What's the length of the whispering gallery and how high is the ceiling at the center? So let's draw a whispering gallery, and we'll put it on an axis. So here is the ceiling right up here, and Nick is standing right there, and Kaylee is over here. Okay, it was nice. We conveniently put our ellipse so it's centered at 0, 0, which means we can start to set up this equation for this ellipse. Because centered at 0, 0, we'll know we're going to have x squared over something plus y squared over something equals 1. Alright, now what do we know? Nick is standing at one focus. He's 6 feet from the nearest wall, so this distance is 6. Kaylee at the other focus is standing 100 feet away. If Kaylee's at a focus, her distance is also 6 feet from the nearest wall. All right. How long is this distance right here? That's half of that 100, that's 50. So part A, what's the length of the whispering gallery? Well, it's 56 this way, 56 that way. The length of the whispering gallery, 112 feet. All right, now, how high is the ceiling at the center? We're going to have to complete out this equation. Clearly, right down here, underneath the x squared, that's got to be 56 squared. We have to figure out what this number is right down here, what that b squared is. Well, how far is Nick from the center? He is 50 feet from the center. So we can use that c squared is the absolute value of a squared minus b squared. C is 50, so 50 squared equals, and again, the 56 has to be the bigger one, so 56 squared minus b squared. B squared is going to then be 56 squared minus 50 squared. And you can zap this in your calculator and get that b is 25.219. which is exactly what we needed to know. How high is the ceiling at the center? That's this distance right here. That distance is b, so 25.219 feet tall is that whispering gallery. Okay, thank you very much for tuning in, and you have enough now to get started on this homework. Oh, you could finish this homework for section 10.3.